So very sleek, very narrow to get into very hard to reach places. The top hatch here used to have a metal thumb screw on it, like a finger screw, and that's been removed and replaced with this plastic clip design. Now normally I'm not a big fan of like when people replace metal stuff with plastic stuff, but in this case it makes a lot of sense. There's a finger latch here now where you just push it shut. There's no more screw there, and everything feels made out of that same robust polymer that they make the housing of this analyzer out of. So I'm actually a big fan. I think it looks and works great. Under here is your stand. This is where all your ports are. This is actually a Wi-Fi port that we have in the instrument right now. You can see the power port, the USB, the micro SD card, and then down here we've got an extra port. This could be either for a USB drive like the one we saw in the case itself earlier, or you could put a Wi-Fi, or not Wi-Fi, a Bluetooth module that can actually sync with your Garmin or other GPS device. So if you're using this in the field, for a mining application, you could get real-time GPS data right into your results. So that's fantastic. Now let's change the battery on this thing. I'm going to use 2 fingers and pull this out of here, and I'm going to take a battery from the case. Now check out this battery. A little bit different of a form factor, but notice these 2 grooves on the top. They slide into these 2 grooves here. You can kind of see that in the light. So if I slide that in, and I did it exactly backwards, it's kind of funny, but it slides in just like that. So with the electrodes facing up and into the instrument, and then this just slides right in and latches. Now, the one thing about this new design, you want to make sure both sides latch. That's something I've noticed, but overall, it doesn't happen very often. You just want to make sure everything gets pushed in there really nice. That new battery latch is very, very good, and with the battery in, this thing is balanced right around the handle just like so. So I really like that. I think that's great. Now that we've got power in the instrument, let's turn it on. You just hold the power button on for a second, and the instrument's just going to turn on. It's going to take a little bit of time to turn on, not long, like a minute or so. So in the meantime, let's talk about what we're going to do next. Now, with an instrument like this, we want to make sure we can sort all the alloys in the industry, and we can do it very quickly. So I've got a piece of 6061 aluminum here, and a piece of, this is actually a 6063 melt button. And then I also have a piece of 7075. So, all right, so to log into the instrument, the standard password is 0000, and you can see really quickly, it just logs in. I like that. I'm a big fan of this interface, by the way. So the blue and the white and this interface, the interface talks to you. Down here, it's saying that not ready, detector not ready. So it's still warming up a little bit. If you give it just a second, it'll eventually say ready down in the bottom left-hand corner. And that actually is very helpful, because that, see, it just took a couple of seconds, but now it says ready. So it's kind of giving you that direct feedback at all times. Okay, so now let's take a look at the 6061 aluminum. Now I'm going to just push the trigger one time. I don't even have to hold the trigger because we're using Smart Sort here. And you'll notice that our results got an exact match to 6061 with no light element beam and very quickly. Now 1100 plus or some other alloys could also be a slight match, but the analyzer knows what alloy we're running with. Now we're going to try the 6063 aluminum. These are the 2 most common light element alloys that we see sorted in industry, 6061 and 6063 aluminum. And what we see here is that very quickly we're able to get that identification for 6063, but you'll notice the lights are flashing a little longer. The Smart Sort wants to run the light element grade match beam to get this 6063 grade match. And by doing so, we're able to measure the magnesium and the silicon and the other elements. You'll notice that we got a low reading on the magnesium, but if you look up at the top here, it does say a 15+ second test is required to detect low levels of magnesium between 0.4 and 0.9%. Not a big deal, but it's good to know that as the operator, but we still were able to get that grade match with no problem. Now how about this 7075 aluminum? One press of the trigger, you'll notice that real quickly the beam turns off, so that means we're not going into the light element beam, excuse me, and this 7075 is easy to identify with an exact match within a couple of seconds. That's fantastic. Now if you get into the middle area, you end up with alloys like this. This is titanium 6-4. And titanium 6-4 can be confused both with steels and aluminums, depending on what it is, but you'll see that the Smart Sort actually picks this up right away as titanium. And then it says, oh, there's vanadium, but we didn't measure the aluminum. It says NOM, which means nominal over here. And it doesn't need to run that to actually test it. I could force 2 beams to measure the aluminum with the light element beam and add another 8 seconds of analysis time, but I don't need to do that because the Smart Sort has already done that for me. So how about your standard stainless steels? We've got a 304 here. Let's test that. Now, the 304 stainless steel and the 3016 stainless steel sort is an infamous sort because most metal recycling facilities want to sort these two grades to get and upgrade the stainless steels that they sell based on the nickel, chrome, and moly content of those alloys. So this is 304 stainless steel. We got an exact match with the first beam with no problems. How about 316 stainless steel? Let's give that a try. So 316 stainless steel, you can see that we do a very similar thing. Just in the first couple seconds of running the instrument, we're able to do a grade identification to 316 stainless steel with an exact match and measure all the elements because the Smart Sort knows what alloy this is and says, I don't need to run any other beams. Now, I'm going to run an alloy here called 2 1/4 chrome 1 moly. You'll notice some corrosion on the surface of this. When you have lower amounts of chrome and nickel and steels, you end up outside of the stainless steel range, okay? And you're able to see in just a second, we're able to pick this up as well with that low chrome content. That 2 1/4 chrome is its common name. It also has 1 moly in it sometimes. This does have 1 moly in it, but the point is that this is a shorthand version of this grade, P22 or F22. How about nickel alloys? This is my favorite nickel alloy, Inconel 718. I have some experience actually producing or manufacturing this alloy, and I just really like it. I don't know why, it's the nerd in me or something like that. But 718, exact match right away. Now again, when we look down here, we've got aluminum. It has a nominal value, so we didn't actually measure the aluminum, but we're still able to do the grade match very quickly. That's important. How about some, let's say some coppers or brasses. So here's a brass sample, and I want to be able to grade this brass, because maybe I want to use brass that's lead-free, or I want to specifically use brass that's free machining for a specific application. This is 360 brass, which is exactly the match we got. That is a free machining brass, and you can see almost 3% lead in this material. That's added so that you can machine away this material easier based on how the lead interacts with the metallurgy of this grade. And then on the other side of that, we have this 954 aluminum bronze. So this is a piece of copper that has aluminum added to it, along with some other alloying elements. And that's going to make this alloy a lot harder than you think. It actually heat treats a lot like steels, and it can be just a very hard, nice, useful alloy. We see 954 aluminum bronze used in high pressure bearing applications a lot. So 954 aluminum bronze, but we got C623. But if I tap this up here, one of the things about bronzes and brasses, any copper alloys, is they typically have a couple different names based on how they're made. C954 is actually a cast alloy, but C623 is its wrought version. So there's two different production methods for exactly the same alloy. I can select that same alloy with a different name, and I can easily see that we have a grade match there as well. So pretty cool. The tips and stuff also are great on this handheld XRF, and I think a really good job by Evidence Scientific for a good entry-level handheld XRF. Now, let's take a look at some of the other physical features here. I have on the front here, this is the brand new window, so you can see the stick-on window, and look at that thing. It's flush with the surface of the XRF, and we also have the mesh, the Kapton mesh that reinforces this window to protect it against detector punctures. Now, while there is no active detector protection system for this handheld XRF, there is a very small aperture, and you do get the reinforcement of a nice window on the front with Kapton reinforcement that still does light element analysis, so that's important. Down here, this little black part here, there is actually supposed to be a pin connector there that's not included on the Vanta Element S model. You need to go to a Vanta Core, and that little pin connector is pretty much just for the test stand. It's for the safety interlock, so when you plug the XRF into a test stand, it's going to talk to the test stand with a connector here. We don't have that available on this entry-level XRF, and that's okay. But let me just take a look at this interface. Like, absolutely beautiful. Really nice feedback for the operator. That Smart Sort, it's fast, it's intuitive. If I touch this top arrow, I get to see all the different things in here that I can mess with, and there's a lot of great settings in here. Up top here, choose your method. This is also brand new for the Vanta Element S version 2. We've got Alloy Plus mode. That's what we just used to test the metal alloys, which includes light elements. We have Car Catalyst, which is catalytic converters. We have Coatings mode, Geochemistry mode, which does have a 3-beam operation out of this instrument, which is really cool. We have Lead Paint, which is for testing lead that's actually in paint, typically in old churches and things like that. A precious metals mode, which precious metals mode needs not to be confused with the alloy plus mode that we're using. There's a different elemental range for the precious metals mode. So if you are using precious metals for like jewelry, gold, stuff like that, use the precious metals mode. It'll give you carroting and everything much better. The Rojas Plus mode, or ROSE as some people say, that mode is for looking for basically lead-free electronics. And lastly, there is a soil mode in this as well. All of these are brand new modes for the Vanta Element